Okay, so those are going to come up a little bit again. But then standard deviation is probably the most important thing that you need to know about in stats, and then we'll work with it quite a bit. So there's this little chart here of two fantasy football players who both average 14 points per fantasy game. One of them has a standard deviation of 6. The other one has a standard deviation of 2. Does anybody know what that means? Who said that? How do you know? Do you play a lot of fantasy football? Okay. So, exactly. So, standard deviation is a measure of consistency. So, fill your blank in there, consistency. Which one, Mitch, enlighten your classmates, which one of these players is more consistent? Yes, the smaller the standard deviation, because what that means is that Terrell Owens, the majority of the time, not always, but the majority of the time, he falls within 2 points of his 14-point average. So he could be as high as 16 or as low as 12. Yes? Whereas Marvin Harrison, the majority of the time, has a wider standard deviation, right? He scores within 6 points. So on the bright side, that could be upwards of 20. But on the downside, that could be as low as 8 points per game. So, what's that? It's not the same thing, but I can understand the connection that you're making. There's going to be charts and so on that go along with this. You can kind of see them down below. But there's a couple percentage. When I say most of the time, Terrell Owens scores within 2 points, either above or below, most in this content means 68% of the time. Right? That's over half. That 68% is never changing. Okay? Once you go 2 standard deviations away, so let's go for Terrell Owens. If 1 standard deviation is 2 points, 2 standard deviations is 4 points, yes? So then the percentage jumps up to 95% of the time. So 95% of the time, he's either 4 points above, which would be upwards of 18, or 4 points below, which would be on the low side 10. So 95% of the time, he's between 10 and 18. Whereas Marvin Harrison, double his standard deviation, that's 12 points. So he could be 12 points below, which would be 2, or 12 points above, which would be 26. So he can have an awesome game or a terrible game. Okay? Whereas Terrell Owens is much more consistent. So to fill in these numbers, Marvin Harrison scores within, Marvin Harrison's 1 standard deviation is 6. So 6 of 14, his average. He scores within 6 points of 14, 68% of the time. He scores within 12 points of the 14, 95% of the time. And this is a 95% confidence interval that we'll talk about. We are 95% confident. Honestly, 2 standard deviations is something we use more so than 1 standard deviation. We would say we are 95% confident that Marvin Harrison will score within 12 points of 14. Whether it's 12 points below or above, who cares? But we are 95% confident that that will happen. Could he have a terrible game and get injured in the first quarter and have 0 and be outside of that? 100% he could, right? Anything's possible, but the likelihood of it becomes very, very much less. And then with Terrell Owens, he scores within 2 points of his average of 14, 68% of the time. And he scores within 4 points of his 14, 95% of the time. So each of these players, their curve looks the same. We're going to assume they're both normal, kind of symmetrical curves. They both have an average of 14. Your 14 is right down the middle. I'll put Marvin Harrison on the left and Terrell Owens on the right. You like that, Mitch? Tio? So with Marvin Harrison, his labels are going to look a little bit different. So if you go out and Marvin Harrison's standard deviation was 6 points. So 6 above 14 would be 20, and 6 below 14 would be 8. If you kind of put a bar up here and shade this in, that's approximately 68% of the area under the curve. We've shaded in 68% of it under the curve. If we go out a second standard deviation on the right, we're up to 26 points. And go out a second standard deviation to the left, we're down to 2 points. And if you shade that in, that shading along with the original shading, that together is 95% of the area under the curve. So 95% of the time, Marvin Harrison is likely to score between 2 and 26. Well, thanks for narrowing it down, right? I mean, he's all over the place. T.O., on the other hand, his standard deviation being 2, 2 above would be 16, and 2 below would be 12. So he's just got a much tighter window. Hence the word consistency, right? We're much more confident betting on the fact that he's going to score, about 14 points. And then 2 standard deviations away from him, if you go 2 more, would be anywhere up to 18 or as low as 10. Okay, dope. So if you want to be clear, and we'll do more of this tomorrow, that's your 68%, is that 1 standard deviation away, so the middle section of your curve. Once you go out 2 standard deviations, that's 95%. Those percentages do not change. Okay? Any questions? Okay. So, jump down to this data, and this is all 18 students in a class, and these are their quiz grades. Use your calculator to determine the mean, median, and the quartile. So, let's first talk about how to enter data into our calculator. There's a stat button that says stat right beneath your delete button. If you go to stat and edit, should already be highlighted, you have a couple of lists there. If there's anything in those lists and you want to clear it out, to clear it out, you'd go up and you'd scroll to the top of the list, hit clear, and then scroll back down, and it will all be gone. So if you have anything there, Michael, you should be playing along. Clear it out and empty your lists. Stat, edit, clear it all out. So for this, to do our data analysis on these scores, we're going to type these all in. So 56, just enter, 68, enter, just go ahead and enter all of those in. By the time you're done, you should have 18 of them. Which, without going back and checking them all, if you highlight the last one that you enter on your list, at the very bottom of the screen, if you look at mine, it says L1 with parentheses 18. That means the 18th item on my list is this 100 that I currently have highlighted. So if that's the 18th one on my list, I know I put in all 18. I didn't accidentally miss one. Because that can be frustrating. Maybe mostly for me as the grader, because I don't know if you really got the right numbers or what if you accidentally typed in something wrong. So always be careful of that. So once you have data in, now to calculate the statistics, it's pretty much always going to be the same thing. Hit that stat button again and scroll over on the top of the screen to calc and 1 variable statistics. That's all you want to run. So when you hit that, you get to this screen. List is L1. That is the list that I put all my data in. Hopefully you did as well. I don't have a frequency list, so right now I have L2 there. I'm just going to clear that out. A frequency list would be used if you had 5 people that scored 100, so you'd put 100 only once, and then in the frequency list you would put 5 to show that 5 people got 100. We don't have that here. We typed in every one of these 18 separately, and then you're just going to hit calculate. And then we're going to talk through what all of these mean. Does anybody know what X bar means with this little bar on the top? What'd you say? Average, yep, that's your mean. X bar equals 83.72 repeating. How about this next one? This 1,507. What does this symbol mean? You should know that from our sequences and series chapter. All of them added together. That's your summation notation, sigma. We won't ever use that, but just so you know, that's what it is. This next one is taking all the scores and squaring them and doing summation notation, adding them all. That has a place in statistics. We won't be touching it. And then these two are the standard deviation. Okay? So your calculator assumes that you typed in just a sample of the population. So the calculator assumes that these 18 students are just 18 of a million, so to speak. Okay? We just randomly picked 18 students. So it's giving us the standard deviation of this exact sample. So X is the 12 point, we'll just say 12. That's the sample standard deviation. The next symbol, which is this little cursive looking O thing, is the population standard deviation. So I don't know what calculation it does, to be honest, but it kind of does something and crunches and it says, okay, under these circumstances, this is what the standard deviation of the entire population could presumably look like. Okay? Usually it's a little bit lower. The N is obviously what? The number of data points we plugged in. And then here's what you probably used to use for your box and whisker plot or your whatever 5-number summary, right? Your minimum, your Q1, median, and so on. So I'm going to create a number line from 50, 60, 70, 80, 90, and 100. And I'm going to plot those 5 numbers. So 56 is approximately here, 75, 84.5, 93, and 100. And those 5 numbers create 4 intervals. Yes, 4 different intervals. We've got the top 25%, which is up here, scoring between 93 and 100. The upper middle 25%, scoring between an 84.5 and a 93. The lower middle 25%, and then the lowest 25% scored down here. Okay? What's that? So if you've got 100 people, 25 of them were in this range, so they're very tightly packed, right? 25 of them are in this range, 25 of them are in this range, and 25 of them are down in here. So quartile, quarter, 25%, that's all kind of a review. I don't think a box and whisker plot would come up on your regions, but never say never. The interquartile range is the middle 50%. So that was anywhere from 71 to 93. That's the middle 50% of your data. Why might you look at the middle 50% and not the whole thing? Like, what'd you say? They could be. They could be. And it's like when I'm teaching. Like, the middle 50% is a really good measure for me because she's not here, but we'll talk about her. The Morgans of the world are always going to get 100s or do really, really well, right? And the people who don't care at all and don't do homework and don't do anything, they're always going to be at the bottom, and I can't affect that. I'm going to say, I don't affect Morgan. She's going to get 100s no matter who her teacher is. And I don't affect people who don't study. I mean, like teaching-wise, it's not really a measure of how I'm teaching. But if the middle 50% all fails, well, then I didn't communicate the stuff, the material properly. But if the middle 50% is in an okay place, then I'm okay to move on. Does that make sense? So and Mitch said it, the outliers. And those two people, those two ends of the spectrum would be the outliers. So that's a thing to think about when we're dealing with stats is why might we throw out some data. Forget about the rest of that. If we go to the back, we already talked about the population standard deviation. How do we interpret the standard deviation? Actually, so go back to the front. We are going to use and pretend that this was a sample of 18 students from a larger population. We'll pretend that this is just a sample. So if our standard deviation is, does it want me to use the population? Yes, 11.7. 11.7. Let's round it to approximately 12 to make things clearer. What that tells us is that 68% of the population likely not definitely, likely falls, or scores, I should say, likely scores between 12 points, which is our standard deviation, below the average, and 12 points above the average. Let's pretend the average is about 84. So if we went 12 points below that average, that would be between a 72, and 12 points above that would be a 96. If we've randomly chosen this sample of 18 people, we're 68% confident that when we grab a random name, that they will fall between 72 and 96. Yes? Does that make sense? And 95% of the population scores between, and we want to go 2 standard deviations above and below the average. So that's 24, right? 24 points above and 24 points below. 24 points below is 60. 24 points above is 108. Okay? So those 68%, 95% is a big takeaway. You want to make sure you don't forget those percentages. Okay? And again, you can say approximately or likely. Again, it's that lack of definitive language. That's a good thing here. So we did C and D. So let's jump to exercise 2, where we have data presented a little bit differently. This is a company, and their 50 employees all obviously have a salary. So here are the different salaries, and then this frequency is the number of people that make 25,000. There are 5 people that make 25,000, 21 people that make 32,000, and so on. So go back to your data, edit, clear out whatever's there. We are going to have a frequency list here. So type in your salaries. How am I doing, Mike? That's okay. You can watch if it's more helpful for you. My frequency goes in list 2, so 5, 21, and so on. So far, so good? Okay, now when I run my calculation here, hit the stat, go over to calculate, in one variable statistic still, I do need to mention that I have a frequency list. It's L2. L2 is written in blue above your number 2 key. So you'd have to hit the blue second button and then 2. So second and then the number 2, and it will pull up L2. And it tells your calculator, okay, you're counting a $25,000 salary 5 times. That just prevents us from having to write 25,000, 25,000, 25,000, 25,000, 25,000, 32,000, right? 21 times. So that just quickens it up for us. And then calculate. So we've got obviously all the numbers in front of us. Let's see what they ask for. The mean, 42,000. $60. The standard deviation, I'm going to use I think it will typically tell you what to use, but I'm going to use the sample one as if it's the population one, because I do know that this is all 50 employees. You add up those frequencies, that's accounting for all 50 employees. So that is the entire population of the people who work for that company. So I'm going to use standard deviation 16,736. We'll just round it to the nearest whole number. So that means 68% of the people, approximately 68% of the people, fall within that dollar amount, either above or below this average, somewhere in between those two numbers. Okay? 95% of the people fall within double that, which is like 33,000-ish, a little bit more than that. Either 33,000 above or below that number, which is 95% is pretty much everybody. So anyone that falls outside of that is probably an outlier. So what is the median? And our median is a number that's given to us, 32,000. Why is the median considerably lower than the average? And what do you make of that? Which one's a better representation of the company and how its workers are paid? Right, the median, I would say, right? Again, a place where people, they don't lie with statistics, but they don't tell the whole truth. So someone like the CEO might say, you know what, we're treating our employees really well. They have an average salary of $42,060. That's pretty great. Okay, well, the rest of the workers and someone who's arguing that they don't get paid enough is going to say, well, the median is 32,000. We don't get paid enough, right? Because those are very different numbers. So the person writing the article is going to tell the story that they want you to side with, essentially, with stats. And that's what happens all the time. You could read any newspaper article that throws stats at you, and that's what's going on. They're throwing numbers at you that tell their side of the story. And even if a reporter is trying to be neutral, it's very hard to not subconsciously let that affect the way you're going to interpret statistics. So, again, always be careful, look at all the numbers. Now, the reason it's the median so much lower is because we have outliers, like the CEO who's making $120,000. He's just one person. That huge of a number, and maybe these two people as well that are making $75,000, the vice presidents of the company, they're all making a lot more money, and they're pulling the average up, but they're not a good representation of what the average worker is making. Do we follow? Okay? So again, if we can get anything out of this chapter, it's to be reading statistics with more of a critical eye and more of an inquisitive nature to wonder if this is, fact or kind of trying to push you in a certain direction. Do more or less than 50% of the data set fall within one standard deviation of the mean? Well, we know hypothetically it should be more, right? It should be what percentage? 68%. That's, again, though, that's hypothetical. Is that actually what happened? So if I do one standard deviation above the mean to one standard deviation below the mean, that's 42,060 minus the 16,736. And that's 42,060 plus 16,736. Oh God, what are those numbers? As low as 25,324, or as high as plus 16,736. What percentage actually fall between those two salary levels? So these 21 people do, these 14 do, these 7 do. So what is that? That's 42 workers out of 50. So 84% of them. So your answer to their question would be more. But you can see how, hypothetically speaking, it should be around 68%, right? The less data you have, the further away it can be by chance. But again, those are approximations. And that's, again, why we can't ever use definitive language. Because it's never going to be exactly 68%. Okay, we'll stop there. And I have 2 homework assignments for you. A spiral and a